Number 7. Okay. Find an equation that passes through this point. Okay, negative 3, 5. And is it parallel to this line? So if it's parallel to this, we know our slope is going to be the same. Okay. So if I use the point slope, I have the y minus the y is equal to our slope times the x minus the x. So we have y minus 5 is equal to negative 2x. That'd be plus 3, so it'd be minus 6, multiply there. And if I add this over, I get minus 1. Okay. Okay, part B, perpendicular to this line. So if I have negative 2x plus y equals 0, and I get y by itself, I have y is equal to positive 2x plus 0. So if it's perpendicular, I know my slope has to be the opposite, reciprocal of that. And I know it still has to go through the point negative 3, 5. So same thing over here. Y minus the y is equal to my slope times x minus the x. Solve it out. Be plus 3 times that would be negative 3 halves. And if I add the 5 over, I have negative 1 half x plus 7 halves, which is 3.5. Okay. Number 8. Okay, we want x and y intercepts and slope as well. 3x minus 4y is equal to 6. X-intercept, to find that, we always set the y equal to 0. So I have 3x minus 4 times 0 is equal to 6. That cancels out 0. 3x equals 6, I have x equals 2. That's our x-intercept. Y-intercept is where my x is a 0, so once again I plug the 0 in there for that x. Okay, that crosses out. I divide, I get my y-intercept at negative 6/4, which is negative 3 halves, which is negative 1.5. Any of those answers are fine. Okay, slope, I would get it in slope-intercept form. So I would solve for the y. So subtract your 3x over and divide by negative 4. So I have okay. Number 9. Horizontal and vertical lines passing through the point. Okay, so I have the point negative 3, 7. Okay. I have Hoivux. Okay, Hoivux. Anyway, so x equal my x equals negative 3 here. Okay. Number 10. You're plugging this once in. So Desmos using y1 tilde m x1 plus b. Okay, and that will yield an equation. Okay, about approximately, depending how you round, negative 0.246x plus 35.7. The correlation coefficient is equal to negative 0.96. Okay, this means that it's a negative correlation, so it's going to go down, it's negative slope, and then it's also a strong correlation, okay, because it's close to negative 1. Okay, part B, predict for 40 miles per hour. So you just put the 40 in there. And it comes out to be about 25.9 degrees. Okay, number 11, a little tougher. Suppose that during a storm, rain is falling at a rate of 1 inch per hour. Water coming out is of this shape here with a circular roof, is running down the spout, and it can take 400 gallons of water per hour. Okay, so part A, determine the number of cubic inches of water falling on the roof in 1 hour. Okay, so cubic inches, you're talking about volume. Okay, so volume of this roof is pi r squared h is our formula. Okay, so So we have pi, radius is 20, and h, it's falling at 1 inch per hour. So in 1 hour, it would be 1 inch high. Okay? So this comes up to be oh, I messed up here. Cubic inches. This is in 20 feet. So 20 times 12 is 240 is what I have to have in there. Okay, so if I take 240 and square it, I get 57,600 times pi times 1, is that many? Which is about 180,956 inches cubed. So in 1 hour, that's how much is going in there. Okay. Part B, 1 gallon equals that many cubic inches. Write a formula for a function that computes the gallons landing on the roof in X hours. Okay. So the number of gallons in there is, I just take this number and I'm going to divide it by that many cubic inches, because 1 cubic inches is 1 gallon is equal to that many. So I have that divided by how many gallons, or how many cubic inches makes 1 gallon, times how many hours. Okay, that's part B. Part C, how many gallons of water land on the roof during a 2.5 hour rainstorm? So I basically want to find G of 2.5. So I'm going to take that 2.5 and plug it in there. And there is roughly about 1,958 gallons in 2.5 hours. And then part D, would one downspout be enough? Well, one downspout takes 400 gallons per hour. Okay, let's figure up 1 hour. Okay, in 1 hour, I can take this, okay, so 180,956, divide that by 231, okay, this comes up to be in 1 hour. So from the problem, our rain spout only takes 400 gallons, so that's enough to take care of the water. So I need to take care of that water. Okay.